Hello, good afternoon. Thank you for attending today's webinar. Today we're going to be looking at what's new with Solid Edge 2022 Part 1. We'll be following this webinar up soon with a Part 2, so stay tuned. And we are consistently adding new CAD and CAM content to the Prolim YouTube page. So if you haven't already been following, go check it out and follow so you get all this amazing free content immediately when it's uploaded. A little bit about myself, if this is your first webinar. My name is Creech, and I've been with Prolim for just over 2 years now. I have over 20 years of end-user experience, much like yourselves, and during that time I've worked in the manufacturing, architectural, and automotive design industries. I built a strong working knowledge of most popular 3D CAD design softwares, such as Inventor, CATIA, SolidWorks, several Autodesk products, and obviously Siemens products, such as Solid Edge, NX. As a senior application engineer with Prolim, my focus is on the Solid Edge mechanical and electrical CAD design products. And my career interests include generative design, additive manufacturing, and process improvement, or Kaizen. So with this year's release of Solid Edge 2022, Siemens continues to push the boundaries of product development with exciting new capabilities such as CAD Direct, Design Configurator, Point Cloud Visualization, Accelerator Share, Convergent hybrid modeling, just to name a few. This is by far the best release yet. So for this session, I'm going to focus on what I felt was the biggest and coolest enhancements, in my opinion, for this release, relative to the core CAD modeling features. We'll look at the CAD Direct, which is probably one of my most favorite enhancements to date, where you can now seamlessly integrate CAD geometry from other CAD systems like NX directly into Solid Edge without the need to migrate or translate from any native software. We'll also be reviewing some really cool new enhancements to Convergent modeling, a new hybrid technology that's going to save us a great deal of time and effort. So CAD Direct is a new built-in 3D design capability that improves productivity when working with geometry from popular CAD systems, providing seamless integration. You just insert the files directly into Solid Edge assembly. There's no migration or translation or native files required. All of the files are maintained associatively and are brought in as internal components. The data is stored in the 3D design assembly file itself, preventing data duplication, but also allowing us to insert the inserted geometry to be used downstream design workflows. So let's go ahead and check this out in action real quick. So here I have a Solid Edge model open. I'm in an assembly, and I've already created this base. So theoretically, I'm working on this display tool holder here, and I've already kind of got my preliminary design worked out. But now I wanna bring in the actual display model that I'm going to be using this plate with. So I've been working closely with my CAM team, and they've developed this part in NX, and they have all this files in NX. But unfortunately, I'm in Solid Edge, so up until today, there's really been no other way for me to get this data from NX, with the exception of just having it, having either a version of NX that I can pull from, or having to translate that file over to a Solid Edge compatible file. But now, under the Home tab, if I go to Insert Component, you'll see that I now have this CAD Direct functionality. So I'm going to just hit this CAD Direct button. And you can see, here's my part. So as you can see, this is an NX part. It's a PRT, not a PAR. And I'm just going to select that part. We get a preview. Here's the NX environment here. I'm going to go ahead and just hit open. So I'm actually going to be pulling in this file directly into my Solid Edge assembly. And there we have it. Here's the NX file. I didn't have to do anything. I can play around with it here. I'm actually going to go ahead and constrain this guy here. I'm going to select this circle, and I've already created this this sketch here. So as you can see, it came in backwards. So if I just select on the part, I'm going to go down. I'm going to flip my rotation here. There we go. And while I'm in here, I'm going to go ahead and release the locked rotation too. So I want to be able to move this part around. So as you can see, here's my NX part inside of my Solid Edge assembly. And you can see now I have an internal component. Here's my PAR file. So it actually does, when you bring in the part file, the NX PRT file into Solid Edge, it does convert it immediately into a PAR file. But as mentioned before, this is just an internal part. There's no need to have to manage this file somewhere in an external folder or anything. It's all saved directly into this assembly model. And also as you can see, there's the part here in the feature tree as well. I can turn that off and on just like any other solid edge part. So okay, so that's the first step. So the first step is getting that part in here, and I think that's one of the big key aspects of this new functionality is the ability to just pull that model in and use it for reference or for whatever reasons you may have to work seamlessly with NX and solid edge together. So let's go ahead and take this a step further. So I'm going to go ahead and actually open up NX. So I'm going to hop over to NX now, and this is the same part. And as you can see, I'm in Cam Pro, Solid Edge Cam Pro, not NX. But for practicality purposes, this is the same software. So let's go ahead and make some changes to this NX part. So what I'm going to do is I'm going to scroll in here, and I'm going to get rid of a few of these holes. And then I'll show you the inoperability of the linking between the NX file and the Solid Edge file. So go ahead and go over to my geometry selection here. I'm going to just make some quick geometry changes here. I'm going to delete a few features. And I'm going to go ahead and select a few of these. There we go. Let's go ahead and apply those changes. You can see I've hidden those holes there. So let's go ahead and save this file. Okay, the file saved. Now let's go back to our solid edge part. So now, unfortunately, as of today, there is no indicator that my NX file. So it's like I said, it's continuously looking back at this link to where that original NX file is saved. But there is no indicator that that file has changed. So for now, I just get into the habit of anytime I'm working with NX files that I know are from NX and could potentially be still being used by other users, I got a pretty simple step here. So if I right click on my part from the feature tree, I now have this update CAD Direct geometry. So I'm going to head and select that. So now it's going to refer back to that NX model that we just saved, and you can see now those holes are gone. So I didn't have to delete the file, pull in the new, I didn't have to delete the original NX file because I know it changed, and then go back and have that the revised NX file upgraded or replaced in the file system, and then go back and retrieve the new one. So this is a super seamless process improvement, in my opinion, when it comes to operating with native parts inside of Solid Edge. To date, you may have this question in your mind, but to date, the only other software that this is compatible with today in Solid Edge is NX. So NX was prioritized, and then in the future, SolidWorks and Inventor and other files will be added. That functionality will be added to the software as well. But as of right now, we can just pull in NX parts into Solid Edge. But as you can see, pretty seamless, pretty user friendly. I mean, it didn't take me no time to pull in this NX part. Probably the time it took me to pull in this part, get into the position I wanted it to, go back into NX, make some changes, come back in and update those changes, probably was shorter in time than it would have been for me to just migrate this NX file over into a Solid Edge capable model and pass revision. So definitely, if you guys are in the position where you're going to be utilizing some NX files in Solid Edge, this is a game changer. So next is the Convergent hybrid modeling capabilities. These will allow you to leverage BREP and mesh geometry in the same model without the need for conversion. This is truly unique thanks to Siemens' synchronous technology capabilities. Removing the need to convert mesh or BREP geometry in order for them to work together reduces model development time, contributing to that ever so valuable process improvement. So let's take a quick look at this enhancement, and we'll start by opening up a scanned STL file and open it directly into Solid Edge. So I've got a model open here, and this, as you can see here, I'll just go ahead and kind of confirm it. It is a mesh body, as you can see here in the design body. But I can also change the display of this thing so you can get a better idea. So you can see that this is a mesh body. There are no BREP solid geometry here yet. So traditionally, we'd have to go into our reverse engineering. We'd have to, create some facets. We would have to, remesh the model if we needed to. Then we'd have to identify the regions, extract the surfaces, and then either do a replace face or stitch these all together in order to be able to add some geometry to this part. So now with the new capabilities, you'll see that we're able to just create geometry right on top of this mesh model. So let me go ahead and do that. Go into my sketching command. I'm going to go ahead and select a circle. I'm going to go ahead and lock to this top plane here. Let me rotate around a little bit. I'm going to create I'm just going to create a quick circle here. I'm going to kind of just eyeball it for now. There we go. I'm going to quick select to get my region. I'm going to go ahead and pull that up here. I'm going to make sure I'm cutting the material away. There we go. And as you can see, now we just created a solid feature in this mesh body. So if I go back and toggle the display here, you can see that some graphical issues here, but you can see that we've got there we go. You can see a little better there. Let me remesh this. There we go. You can also see that with the meshing, what happened around the edge of the circle was that it kind of tightened and added a bunch of small triangular mesh around that in order to help me generate that material. So, but as you can see here, now we've got a cutout, so it is a feature, and in fact I can even select this and now go as far as making some modifications to this just as I would in synchronous technology. And now I've updated. So really, really cool technology of using this hybrid functionality within a BREP. So again, process improvement is key and one thing that I really try to hone in on as much as I possibly can. So let's go ahead and add a round to this feature so you can kind of see a little bit more. We'll do 1.5 is good. So what you're going to see here is currently today with this functionality, so this is where you're getting the hybrid kind of sense of things here. So we've got a BREP geometry feature here, and we've got the mesh body here, but you can kind of see that this also is a mesh. So in order to blend these surfaces, it's actually taking that mesh body into and kind of seamlessly running it into the BREP material. Maybe if I change this view, you can see a little better here. So you can kind of see that new feature, even though it is a round, it is a feature, it is still also mesh. And then if you look at the hole we put in there, it is not. It's just a standard BREP geometry feature. So that's a pretty cool feature here. So let's go ahead and do a couple more quick things here. Let me go ahead and snap to that. Rotate around a little bit. I'm just going to create a simple little profile here. Arc here. There we go, and then we'll do the same thing here. So now you can see that I've created a boss on here. So I can not only subtract material, but I can also add material or geometry directly right onto this into this mesh body. So take that a little step further. I'm going to actually create a chamfer on here. There we go. So again, this is really taking advantage of this hybrid functionality. And again, I can't repeat this enough, where I'm really getting, I'm really taking advantage of this new features, this new technology in order to help me streamline some of my design processes. So back to that process improvement. If I'm able to save me 1 or 2 clicks an hour out of my day, over a week's time, over a month's time, that's really going to save some time and effort and ultimately save me and my company money. So another really cool feature here in Solid Edge 2022. So enhancements to the subdivision modeling are really groundbreaking. Subdivision modeling is already a really cool feature within Solid Edge, but the new bridge command effortlessly connects edges or faces or subdivision cages and creates a lofted structure between them. The curve can also be used to help control the overall shape. To further refine the shape of the part and have it match the outward curve of the machine, we'll be using the new Align to Curve command. Simply select the cage vertices, define the direction that you pick on the curve, and then during this process, it's possible to manually define a spline curve or even use gestures by clicking and dragging to fluidly adjust the form as required. Point cloud visualization has also been enhanced as well. For those of you with active in additive manufacturing and reverse engineering fields, I'm sure this will be a fan favorite. It's so easy to use and works with real-world environments. And always, Siemens continues to greatly improve upon the way Solid Edge deals with huge assembly files. So for this example, we'll go ahead and hop into our subdivision environment. As you can see, we're still just in the standard modeling environment. But by double-clicking on the title here, we enter into our subdivision modeling platform. So you can see we've got all of our subdivision modeling relative commands. So if you're familiar with this software, or I'm sorry, this module, these are all pretty new, but we do have this new bridge command. So let's go ahead and explore this really quickly. This is going to allow us to connect edges by selecting the cage element. So let's go ahead and do a couple of these real quick so you can kind of see what I'm talking about here. I'll reduce my number of segments here. Some quick visuals. So as you can see, very quickly, I didn't have to create a sketch and then extrude this sketch. So let's look at this a little closer this time. This time I'm going to slow it down. I want you to pay attention to, when I select a cage, you can see that, kind of hard to see here against this white background, but if you notice this top left-hand corner, it's got a little vertices here. The location of my cursor is going to basically identify the closest corner or edge that it's predicting that I want to select. So keep that in mind, because if you're familiar with the sheet metal contour flange, or I'm sorry, not contour flange, but the lofted flange, it gives you kind of a preview of the vertices. So let's go ahead and select this. I'm going to pick this top right corner as my control point. And I'm going to select this top portion here. Notice I get a quick preview. You can see here the green line here. Depending on where I put my cursor, it's kind of giving me some indicators of where it's going to push that material to. So I'm going to go ahead and select that. And you can see that because I kind of crossed them from this back side to the front side, it's actually put a twist in that geometry. So again, depending on your desired result, this is either something that you want or you don't want. So I would always be cautious and be aware of where you're placing your vertices when you're selecting that geometry, because as you can see, two of the same profiles, using the same command gave me two, kind of drastic, different looking geometries. And again, this is a cool command. I can play in this thing literally all day long. So I'll go ahead and create a few more simple. And again, I have access to my quick pick, so I can select a few things from here. Pretty user friendly, pretty easy to use. This is really a fun environment to play around in. And again, I can play with this stuff all day long. So I'll go ahead and create a couple more here. Now, a really cool thing about this functionality too is this bridge command, is it will also allow me to create surfaces across the top. So let's go ahead and show that real quick. So I'm going to go ahead and select this cage here. I'm just going to kind of just run through it. And let's go across to here. There we go. So we can also, we don't have to go vertically. We can also come across horizontally and capture some geometry. Now, another really, really cool thing here is the ability to intersect existing geometry. Go. So as you can see, just seamlessly, I was able to go in and create some intersecting geometry. This is now, let me close the subdivision modeling environment. So you can see, really, really cool stuff and very easy to use. And, you get some really cool results. And again, I'll show a couple more examples of a couple of different scenarios of how beneficial this software is. But, again, I didn't have to create some surfaces to get these contours. I didn't have to create some complex sketches and extrude. This is literally like playing with Play-Doh. I mean, it's literally the same thing as playing with Play-Doh, but you're not getting your hands dirty. So let's look at another example real quick. So here we've got 3 pieces of subdivision modeling geometry. And let's go ahead and hop back into our subdivision environment. There we go. So we can identify by the cages and also all the tools that are available for just the subdivision modeling environment. So now I'm going to create just some quick geometry using this. Again, we're going to be focusing on this bridge command for the most part here in this activity. And again, being mindful of my vertices and where I'm pulling that material to and from. You can see in a matter of just a few moments, I'm able to go in and really create some cool, quick geometry here. I'm going to just kind of build a little structure here. Oh, this time I'll pick the bottom side. Let's go here. And this probably won't be super symmetrical, but let's see what happens. Let's pick this bottom side, this bottom side. So as you can see, this is my desired result. I didn't want it to be symmetrical. Just kind of show you the differences and how easy it reacts and manipulates. But now we're going to kind of focus on this this curved line here that we've got here. So we can actually utilize this this contour to kind of help us create some subdivision modeling geometry. So let's go ahead and click the bridge command again. I'm going to select this bottom cage. Now again, it's very mindful that, again, back to the vertices. So when I select this cage, I'm going to want to make sure that my vertices is connecting this 3D sketch that I have in place here. And because I want to utilize it. If I were to select it on this other side, it might not give me the desired result. So I'm going to go ahead and select this side. Now once I got it selected, you can see it's already kind of generated this straight across path here. But I do have this other feature here, this shape curve. So I'm going to select the shape curve. Now it's going to give me the ability to select on some edge or geometry that I can basically confide to. So you can see that it gives me a real sharp kind of bend. It's looking at this contour, but here's where I'm going to kind of express the segment. So here we've got 2 segments. It just means we've got 1 segment here, 1 segment here. We have the ability to improve this contour by adding additional segments. So as you can see, the higher segments I add, the more that this geometry is really conforming to that sketch, that sketched curve. So let's crank it up to 15, and that probably will get me pretty close. So as you can see, that takes it from just kind of 2 kind of hard chunks. Now it's kind of more of a contoured, more aesthetically pleasing contour there. So let's close the subdivision. So now you can see that I can go ahead and hide the my 3D sketch here. Now you can see just within 30 or 40 seconds I was able to create a pretty cool looking little bracket or whatever you want to call this thing. And again, very user friendly. It didn't take much effort at all to create this design, and anytime I can go back in and make changes as needed. So pretty cool. I'll show you one more example here real quick. So we'll look at this part. So up until this point, we've used the bridge command. We're going to go back into that bridge command. Again, I'm in synchronous. This was created in synchronous, so it's pretty easy for me to jump right back into the subdivision environment. But we've been using the bridge command to add geometry up to this point. But I want to show you that we also have the ability to utilize this tool to cut away material, as you can see here. So not only can I add material, but I can also cut away material based on my need. So now we'll look at one more quick example of the contour So I'm going to select this bottom cage here, and again, I've got this 3D sketch here, and I want to pull this geometry down. Now, notice that this is an open-ended sketch. It's not closed. I don't have to build my cages from cage to cage. I can also define a cage out in space. So let's go ahead and select this bottom rectangle here. Again, keeping kind of visual on my vertices. I want it to be connected to that 3D sketch, so I'm going to select that corner. Hit OK. And now, again, I'm going to go back to this shape curve. So before I select this, I'm going to go ahead and crank my segments back down to kind of visualize that again. And I'm going to select my 3D curve. So if we look at this straight on, you can kind of see that it's not really giving me the effect that I'm looking for. This is the 3D sketch is more of a kind of candy cane into it. But as you can see, when I add the segments, it's really conforming to that sketch even higher. So the higher my segments are, the more control I have over the 3D geometry. You can see that's a pretty tight. I could probably crank this up a little higher to get even better quality out of that, to get a really fine curve. We'll leave it at 15. Close it. And there you go. So I've got a, I'm not constricted to just bridging two surfaces or two edges together. I can actually create geometry out in space and terminate it out in the middle of nowhere if that's what I needed to do. Let's look at one more quick example of this. So as I mentioned, the subdivision modeling isn't new to 2022. It came out in 2021, and this profile here might be familiar to some of you guys. It's the Finamac controller for one of the data sets for What's New Solid Edge 2021 for the subdivision modeling. So you can see this is kind of just an image here to give us a quick reference of where to create our model. So again, kind of mentioned the subdivision modeling is great for just kind of molding and mocking up kind of a Play-Doh rough prototype, but it can go as far as your finished product. But for this purposes, we're going to just create a rough design here. So I've already got a rough kind of an outlay of kind of what the rough size of the controller would be. But now we're going to kind of look at this other, and notice here I'm in ordered this time around. So the last three examples were in synchronous. So in order for me to get into my subdivision modeling environment, I've got to actually I've got to edit into that feature. So now we're going to look at another new feature with Solid Edge 2022 in the subdivision modeling. So split, again, isn't new, but you can notice we've got a drop down here. So now we have access to the split with offset, which is a really cool tool. So this is going to allow us to offset edges towards user-specific values. So let's see this in action. So I'm going to go ahead and select these two profiles here, and you kind of see what it's doing. It's kind of giving me this, this quick little cut-in. So I've been able to kind of create that. That was just two rectangles, and now I've got a split with an offset. So it generated this offset, and if I hide this again, you can see we're kind of getting into this shape of this monitor, this screen that we've got designed here. And now we're going to use this offset command here. This is going to allow us to offset these steps. So now again, I'm going to select these two inside offset parameters that I have. Got two segments. I'm going to make sure that I'm doing a lift and not a tip. So that lift is going to just pull that material straight up as opposed to tip giving me more of a sloped angle. We'll leave the segments at 2 for now. We'll hit OK. So we'll leave it at 15. So what you can see here is that we've actually lifted up that profile. So now we've got a closer, so hide this again, we're pretty close to where the display monitor is. And this is going to be a pretty close representation of what we're gonna want to design. So another just really cool, handy new evolution to the subdivision modeling. So next we'll have our new point cloud visualization for assemblies, which provides the confidence you need to position new equipment in a setting especially useful when retrofitting in existing factories or plants. Point clouds are the simplest form of 3D models, basically collections of individual points plotted in a 3D space. They are created by scanning an object or structure typically using a laser scanner or even your iPhone in your pocket that are now equipped with LiDAR scanners and cameras. This solution provides the ability to visualize extremely large, full-color cloud points and supports various file formats, including 2 new Autodesk formats. This capability can provide confidence in the decision of where to position these new design equipment, and it's available within Solid Edge Premium subscriptions. So let's take a quick look at this one. Hop back over into Solid Edge. Now I have this large assembly open here, and let's pretend that I'm working on I'm retrofitting this equipment. So I went out to the factory where this is going to be installed. I've taken some measurements, and I'm back in my design house. I've created this, what I feel is a pretty good prototype of the customer's needs. So what's next? So next would be for me to build this thing, based on the information that I took from it, whether it was just pictures or, laying down a tape measure and measuring the areas where I need. Unfortunately, if I were to just build this and send it to the customer and have a technical team build this in place, unfortunately, we're not going to know whether it fits or not until it's in place. So what's the next step? So the next step is actually allowing us to take visual point cloud data of the area that we're going to be retrofitting to, and then being able to use that in this 3D environment. So let's go ahead and look at that. So now if I go to my Tools tab, I now have this new point cloud reference command. So let's go ahead and select this. So as you can see here, I've already got a factory.pts. This is a point cloud file type. But if you look down here before I open that, I want to just explore this for a moment. You can see that we have ACS documents. We have the capability to open up PTS and PTX, XYZ, LAS, STL files, PLY documents, which I believe are Polycam, and then RCS and RCP documents. So we've got, building on this technology, this growing technology, Siemens is really taking advantage of allowing multiple different file types in order to take advantage of this new tool. So let's go ahead and open up this tool here. Now, keep in mind, as soon as we open this up, we got a couple of options here, a couple of additional steps. So one, we've selected the file. Next, we want to look at the options here, and I think these options are pretty valuable. So as soon as I open up this file, it's going to zoom to the point cloud when displayed. So it's basically going to give me a full view of the point cloud once it's imported, and then display the steering wheel to move the point cloud when it's complete. So the key here is to allow me the ability to, once this point cloud comes in, it's probably going to come in somewhere out in space. So I'm going to want to be able to manipulate that as soon as it comes in. So immediately as soon as the point cloud data is uploaded, I'm going to have the ability to move it around just as it's completed. And then again, save data for fast open. Now this is key here. So for this particular data set, this cloud data has about 300,000 points. I'm sorry, I think it's 30 million points. There's several million points of cloud data in this one file type or file set. So the first time I opened up this file, it took probably 5 or 8 minutes to open it fully. But if I have this saved display data for fast open selected, that's going to retain that information so that the next time I open it, it's going to open up super quick. And I do have the ability that, for some reason, I pulled in the wrong data, I can always clear it so I'm not taking up, some valuable space. So let's go ahead and stay with these options. Hit select for OK. And now I have the ability to make some further controls. So the density is at maximum. I'm going to go ahead and let's put this at let's leave it at maximum, and then automatic for the size. Actually, let's go to minimum. Medium. Let's do medium. Okay, now I think we're ready. So let's go ahead and hit OK. Now again, this is probably going to take just a few seconds here, but if this were the first time I was pulling in this large data set, it would take a few minutes to open up. But there we go. So now the point cloud data has been pulled in. You can see that because I have that setting selected to give me that steering wheel as soon as this is placed in. If we just take a quick glance, we can see that our model is kind of out in space a little bit. It's not really in ideal position. So what I'm going to do is I'm going to go ahead and move my my steering wheel. Let's go ahead and put a base reference point to the floor of this 3D point cloud data. And so what I'm going to do is I'm going to be moving the cloud data as opposed to moving my assembly around. It's just much easier to move this one piece of data as opposed to trying to manipulate my entire assembly. So just, using those synchronous style steering wheels, you can see that I can pretty easily manipulate this to where I want it to be. Let's go ahead and pull this out about 3,500. There we go. Okay, so now we've got this this 3D point cloud data pretty close to what we want to see here. I'm going to go ahead and activate a couple more parts here. So let's go ahead and activate. Oh, I don't want to do that. So if we look at this front view here, we can see that we've got some potential collision here. So we want to make a change to it. So one really cool thing about this point cloud data capabilities are that if we go to our inspect tab, we actually can measure this point cloud data, which is really cool. All elements. So as you can see, I'm actually selecting the point. It's moving to point clouds, moving to each one of these points. There we go. So, this is going to be really handy if I need to kind of determine if I need to make some last minute changes or not based on some visual cues here that I've got. So let's go ahead and close this, and I'm gonna go ahead and make a quick change. So I'm gonna let's go ahead and edit this. So I'm gonna bring this pipe down a little bit just to give me a little bit extra clearance. So bring that down to 1200. Close my sketch. So my pipe follows. So I'm able to utilize this, this point cloud data to really kind of help me really get this thing in a position. It looks like my plate my pump might be out of position as well. So let's go ahead and move this guy over. And again, just using these simple synchronous steering wheels, I'm able to kind of manipulate and move things around based on what I need. There we go, looks about right. There we go. So, again, this is extremely valuable, tool that I can utilize here in the 3D environment, as opposed to, the potential of losing thousands and thousands of dollars of rework time, being able to confirm this information in this environment, as opposed to once it's shipped to the customer and we've got, a team on the floor that's actually installing this stuff and then running into delays or finding some issues that may be, not so great at the end of at the design or the installation phase of the project. So again, this is going to allow us to kind of make some further visualization and some inspections and final checks before we actually produce this thing and send it to the customer. So that's the new point cloud visualization for 3D design. So Siemens has been investing heavily in the large assembly modeling performance realm, and it shows. For the third straight year, they have achieved orders of magnitude performance improvement, and it was already pretty fast before. But Solid Edge's new capabilities make it even faster. The new assembly preview mode allows you to enter the preview mode in order to reduce the amount of data that is loaded. You can view, rotate, pan, and even change configurations prior to loading the full assembly. It switches on based on the size of the assembly and opens in seconds. So let's see a quick example of this real quick. So I'm actually going to open up this same file that we have here, but I'm going to actually just open up the large performance mode version of it. So you'll see that once I open this file, the 3D design is populated, but you can see we're in this very limited view mode. So we don't have our traditional tools available for us to start modeling directly. So this is, again, just a preview mode. So I have the ability to go in and kind of activate some of these parts, but really that's about it. I can just kind of identify what's on the Pathfinder, what's in the assemblies and sub-assemblies. I can look at everything, but I don't have much other control over that. So, but what this does is this allows me to bring this model in super fast. Maybe I just need to look at it for a second and just make some visual verifications that it's the correct assembly and configuration, before moving on to load the part. So again, if I'm in a crunch and I need to just open up a file quickly, this is going to be huge. So if I go into the options menu here, I want you to see that Assembly Open As now has this new feature here. So it's Open Assembly Preview for large assemblies. So this is a global selection, meaning when you have this activated, it's going to activate every model that fits the criteria in this assembly mode. So again, but one cool thing is if I want that selected, so I'm going to hit OK. But if I do go to Open, and it's a global feature, but maybe let's say I've got a model that I want to go ahead and just open it up directly, even though I don't want to have to go to settings and toggle those back and forth. When I just navigate to the file I want, I can always just deselect it here. If I want to open up that full-blown model in its modeling environment and kind of bypass that preview mode, I have the ability to just deselect it here if I need to. But for this purpose, we'll go ahead and leave it active. So I want to kind of show you again. We have all the abilities to navigate and look at this part how we see fit. All the normal navigation tools are available, but you can see we have this edit assembly. So we've got a couple of different options here too. So we can just go right in and edit the assembly and just opens up everything. And depending on the size of your assembly, this may take a little bit more time. But look at this edit assembly with options. We'll go ahead and look at that. And this is going to allow you to make some further selections. So Assembly Open As Auto Select. And we'll toggle through here. So what's really cool here is we have this last save. So let's say we have a specific configuration. Let me cancel this real quick. And let's just say we only want to show. We just want to look at this this small portion of the model. We just want to look at this guy here. So I can save this. And now when I go to open the assembly the next time, if I have this last save selected, this is what this is going to do. It's going to pull in the very last configuration that this file was saved in. So let's hit OK. So essentially this is going to load in the parts that I have saved the last time around. So maybe I'm only working on this specific subassembly. And then for the next few days, I'm going to be working on just this one individual component or area of the machine, and that's what I want. So as you can see, I open it up, and it didn't load into the other parts. So now I'm back into my normal, modeling environment, where I can go ahead and make changes to these sub-assemblies or individual parts. But that's based on my last saved configuration. So if I wanted to show, now I'm off of that one and I'm into this one. So now when I save this file and I go back into that preview mode, when I go to select if I have that last save selected, when I go to open to make the edits, this is what's going to be the configuration that opens. So again, this is kind of in combination of using the configurations together with some other things. So there are a couple of different methods as to how you can kind of manipulate this, but this is just allowing you another option and another access point to kind of navigate through these really big, large sub-assembly assembly files to kind of help you, get your product to the floor faster. So again, if you're constantly working with large assemblies, you guys are really going to love those new features. So in summary, we saw some really awesome new features with the Solid Edge core modeling aspects of the software. We seamlessly integrated NX part files directly into the Solid Edge assembly environment without having to translate or migrate the data. This is a huge time saver in my opinion. And we saw the new Convergent hybrid modeling feature that now allows us to work with BREP and mesh geometry together in the same model without the need to convert anything. Say it with me, class. Process improvement. For subdivision modeling, we saw enhancements to the already very cool, very easy to use mode within Solid Edge. The new bridge command effortlessly connects edges or faces of subdivision cages and creates a lofted structure between them. And we watched how easy a full color visualization of point cloud data can be brought into the Solid Edge assembly and used as reference data to determine the best location and fit for this new industrial equipment. Well before ever finding out the hard way, after it's shipped and installed of this, this very costly equipment. And finally, we saw how Siemens continued commitment to solving the ever so popular challenge of opening and working within these extremely large assembly files. So now at this time, we'll take any questions that you may have.